11, I will connect the area model and the partial products method to standard algorithm. So for the last few days, we've been talking about multiplying a 3 and a 4-digit number times a 1-digit number using standard algorithm. And today we're going to talk about a different strategy called the area model. If we've been thinking about multiplying numbers like 347 times 4, so this would be 3-digit times 1-digit. Well, the area model is going to help us for when we decide to do 2-digit times 2-digit, like 44 times 26. So that's why we're learning a new strategy today. In your journals, go ahead and write today's date and lesson 11 area models and partial products. Make sure you write that really neatly so that when you go back and look at it, you'll be able to read what you wrote. Okay, so first of all, draw this rectangle just like I have here and label the length 200 and the width 8. Then I want you to think back to how you find the area of a rectangle. Once you think you know how to find that area, I want you to write it inside the rectangle. So if you did 200 times 8 like you do to find the area, you should have had 200ths times 8, which would be 1600ths, which would be 1,600. So you can think of the area of this rectangle just like doing 200 times 8. So if we thought of that as being part of a bigger rectangle, like 200 times 8, and then 3 other rectangles that were a little bit smaller, we could think of this as 234 times 8. So if we look at this problem this way, and then we just looked at the area of every one of these smaller rectangles. With all these zeros, it makes it easy enough that you can multiply this in your head. So we know that this is 1,600. And if I had 3 tens times 8, that would be 24 tens. And then 4 times 8 would be 32. So now all you'd have to do is add all of these numbers together, and you could get the product of 234 times 8. So it's like 8 times 200, which is the first rectangle, 8 times 30, and 8 times 4. So if we multiplied or added all that together, we get 1,872. So let's look at what that would look like compared to whenever you were finding the partial products. So first of all, we did 200 times 8, which was the large rectangle. So I'm just going to write that here, 1,600. And we did 30 times 8, which was 240. And then 8 times 4, which is 32. So again, if I added that together, it would be 1,872. So let's look at that next to partial products. So in partial products, instead of starting with the hundredths, we always started with the ones. So if I had 4 ones times 8, that would be 32. And then 3 tens times 8, which is 240. And then 2 hundredths times 8, which is 1,600. So notice how these are the exact same numbers, they're just in a different order. Because of the community property of addition, it doesn't matter which order I add these in, they're still going to be the same answer. So basically that is the area model, and that's what we're going to be practicing today on our problem set. So go ahead and get out your problem set, write your name at the top, and we're going to practice this area model. So you can see over here we have a rectangle, and the first thing we're going to do is we're going to label this rectangle. So we have the 4 over here, that's just going to be the width, so label that 4. Then each of these numbers is going to be the width of the rectangle. 20, and then 5. So if you just multiply each of these separate rectangles, we can get the area of all 3 of these. 1,600, 80, 20. So down here we're just going to write what we multiplied. So we multiplied 4 times 100, 4 times 20, and 4 times 5. So over here, I'm going to use the standard algorithm, 425. And so first we're going to do partial products. And I wrote this kind of big, a little bit smaller. So let's start with 5 times 4, which would be 20. 210 times 4, which is 8 tens, which is 80. And then 4 hundredths times 4, which is 16 hundredths. Add it all together, which would be 0, 1,000, And then I'm going to use standard algorithm right next to it. So 425 times 4. 5 times 4 is still 20, but we're going to carry the 2. And 2 times 4 is 8 plus 2, 10. And then 4 times 4, which is 16, plus 1, which is 17. So notice we got the same answer. And if I came over here and added all three of these areas together, I would still get 1,000. Right here. So again, we're going to label this rectangle. If you feel like you can do this by yourself, go ahead, and then you can just come back and press play and see if you got it right. If not, you can just follow along with me until you feel comfortable with it. 7. Oh, we're going to have to figure this out ourselves here. So we've got 534. So let's use expanded form. 500 plus 7 plus 4. So this is 530. So we've got 500 times 7, which is 3,500. 3 tens times 7, which is 21 tens. And 4 times 7, which is 28. So we do 7 times 500, 7 times 30, 7 times 4. Okay, so let's solve this using partial products. I'm going to write a little bit smaller. So you notice the same exact numbers that I used over here, except they're going to be the different order. I'm going to do 4 times 7 first, which is 28, and 3 tens times 7, which is 210, and 5 hundredths times 7, which is 3,500. Same numbers, they're just in a different order. You add all those together, you get 3,738. So I want you to try to do this 534 times 7 in standard algorithm by yourself. We've been doing that for a few days. See if you can do that by yourself. And then come back and I'll walk you through it. So 4 times 7 is 28. 3 times 7 is 21, plus 2 is 23. 5 times 7 is 35, plus 2 is 37. So you notice we got the exact same answer on both. One more we're going to do. So I've got 209 times 8. So let's come down here and do this part first. So I'm going to do 8 times 200 plus 9. Notice it's only 2 because there's no tens. So I have 8 and I have 209. So I'm going to have 200 and 8 times 9 would be 1600. Okay, so again, we're going to do this problem 2 times. 209 times 8 with partial products. So 9 times 8 would be 72. 8 times 0 is 0, so I don't have to write that. And then 200 times 8, which is 1600. That would give me 1,672. All right, so same problem using standard algorithm. 72. 8 times 0 is 0 plus 7. 2 times 8, which is 16. So 1,672. Now, so let's take a look at the back. So you'll notice that the directions say use partial products method. So first of all, we're going to read the problem. Kayla's school has 258 students. Janet's school has 3 times as many students as Kayla's. How many students are in Janet's school? So I'm going to draw a picture, and you'll notice because it says 3 times as many, this is a comparison problem. So when I do my tape diagram, I'm going to draw 2 separate tape diagrams. I'm going to just put C for Kayla's and J for Janet's. And it says that Kayla's school has 258 students, and then Janet's school has 3 times as many. So we're going to put 3 times as many boxes here. And the label is 258 in each box. So now I'm going to go back and look at the problem and see exactly what it was asking. It says how many students are in Janet's school. So this is actually what I'm trying to find out. I could add 258 3 times, but the more efficient way to do that would be to multiply. So I've got 258 times 3, and the problem specifically says to use partial products. So I'm going to do 8 times 3, which is 24, and 5 tens times 3, which is 15 tens, and 200 times 3, which is 600. I'm going to answer that question. How many students are in Janet's school? So just write that sentence. There are 774 students in Janet's school. So for number 3, it says model with a tape diagram, and it says 4 times as much as 467. If we're using a tape diagram here, I have 4 times as much as 467. So I know that I have 467. And then if I have 4 times as many, think to yourself, how many boxes would that be? 4, right? That would be I've got 2, 4. Hopefully your boxes look a little nicer than mine. Where would be the part of this tape diagram that I'm trying to figure out? Would be the total, right? So you draw your bracket and put your question mark here. Now you'll notice that this does not tell us what kind of multiplication to use. So we can use whatever kind of multiplication that we'd like to use. I prefer to use standard algorithm because it's a little bit faster. So let's just go ahead and do 467 times 4 doing standard algorithm. If you don't need to follow along with me, you go ahead and do it by yourself and then just come back and check and see if you got the same answer. 28 and 24 plus 2, which is 26, and 16 plus 2, which is 20. So I get 2,068. Because this really doesn't ask me a question, I'm not going to write a sentence to answer it. All right, so last few problems here. Solve using the standard algorithm, the area model, the distributive property, or the partial products method. So this time you get to choose. I'm going to choose what method I want to use, but you can choose to do whichever method you want to do. So I'll probably do the area model on these just because that's new. But if you want to go ahead and do partial products or standard algorithm, you could just check and see if you got the same answer as me. So if I did 7 times 5,131 and I was using area model, I would have to use the distributive property, or actually it would be expanded form 5,131. I'm going to multiply all of that times 7, so that would be 35,700, 210, and 7, and then I just have to add all those together. I think I can probably add this together in my head, because this is 910, so this would be 917, so it'll be 35,917. So if you did standard algorithm, just see if you got the same answer as me. All right, so now we've got 3 times as many as 2,805. So if I did area model, that would be 2,805 times 3. So that would be 6,000. 24 hundredths, 15. And let's see if I can add this in my head. So that would be 8,415. So we're going to have to model this one. A restaurant sells 1,725 pounds of spaghetti and 925 pounds of linguine every month. After 9 months, how many pounds of pasta does the restaurant sell? Write your answer as a statement. So I'm looking at this thinking this is probably going to be a 2-step problem. So first of all, it's not comparing anything. So when I draw my tape diagram, I just draw one tape diagram. And I've got 1,725 pounds of spaghetti and then 925 pounds of linguine. So if I'm going to figure out how many pounds of pasta they sold each month, I'm going to have to find a total here. So this is just going to be basic addition. So 1,725 plus 925. So when I add that together, 2,650 pounds of spaghetti. So this is the abbreviation for pounds. So now this says after 9 months. So if this is 1 month and I want to know 9 months, now I have to multiply 2,650 times 9. Because I don't have that much space, I'm just going to go ahead and do standard algorithm here. So this will be 0, 35, and then 6 times 9 is 54, plus 4, which is 58. And then 2 times 9, which is 18, and 18 plus 5, which is 23. So that's 23,800. So if I go back and look at the question, how many pounds of pasta did the restaurant sell? So I would say the restaurant sold 23,850 pounds of pasta. Okay, so that's basically area model. You can see that standard algorithm is definitely more efficient, but we are going to use this area model when we start to do 2-digit times 2-digit. So it is really important that when you're doing your exit split today in your practice that you really focus on how to do this. You'll need to do it again later.